Hello everyone, my name is Muhammad Ahyuddin bin Saifuddin and I am from the Group 7, Section 1, and I want to introduce my group members. Today we would like to present our video presentation. Enjoy it!
Hi, Assalamualaikum. My name is Muhammad Akil bin Ramlan. I am the part of this group. In this project, we were assigned to construct a tower by using a straw and then carry out a wall structure analysis when a certain amount of load was applied upon it. Based on our meeting, our group has come with a rectangular shaped tower with a support at the base and consists of 3 levels resulting in 30 cm of height. In our project, we must achieve for this case study, which is we had display and practice knowledge of solid mechanics by solving assignment and project by using a mechanic software. We had demonstrate effective communication, solving solid mechanics, practical application. That's all about the introduction.
Hello everyone, I'm Kupandram. I'm here to give a presentation about our project literature review. First, let me introduce to the straw. Straw are made of a stock of high grains yield, example quinoa corn, wheat, flour, rye or rice. Later, it introduced together and covered with mortar skin and make a solid, energy effective and environmental home. After that, let me introduce with the tower. We all know as tower is a tall design, wide, frequently by critical factors. Tower are recognized from poles by their absence of fellow wire and subsequence. Tower is not built in the current years. It has been introduced by ancient occasions. There are many historical pinnacles around her, such as Sonus Tower, broad structure in Scotland, Moroccan city, and more out there. There are different type of structure elements for tower building. First, rigid frame, known as concealed by the inflexible joint, for example welded joint. Then truss, which called pin connected joints. Third, beam. Beam is a structure individual from its design, make shear and twisting inside shaft. Fourth is cable and arcs, which links are generally suspended at their closures and they are permitted to list. Last, plates and slabs, normally made of metal that are frequently found in floor and tops design.
For the methodology, the concept of paper tower to design and build a model of a loading bearing tower by using a straw and if fastened by masking tape provided. No other materials may be used. Straw may be cut or snip if desired, and they may be bent in any manner desired. The size of the tower is in the range of 25 cm in length and 25 cm in width. The model of the tower must be not more than 0.7 kg. Development of each stage of design. First, the height of the tower will be measured before the loading process begins. To qualify, the tower must be at 30 cm in height. 2. The top of the tower must accommodate a load 30 kg. 3. The load will be placed on the highest part of the tower. 4. Place the loads one by one on the top of the tower until it collapses. So this is the picture for fabrication of the prototype.
My name is Ryan and my metric number is AN200207. Today I'm gonna elaborate about the calculations and the formula involved in the straw tower. First of all, the length of the straw tower is 25 centimeter and the width is 25 centimeter. The height of the straw tower is 30 centimeter. The load involved in the calculation is 5 kilos, 10 kilos, 15 kilos, 20 kilos, 25 kilos, and 30 kilos. The weight is calculated by using the formula F is equal to mg, where m is the mass of the load and g represents the gravitational force. The largest weight calculated is 294.3 Newton, whereas the weight that can withstand is W5, 245 and 25 Newton. The stress is calculated using the formula stress is equal to P over A, where P is the pressure and A is the surface area. The surface area of the base is 25 cm times 25 cm, which we get 625 cm square. The value is then substituted into the formula to obtain the stress. Next, we will calculate the strain of the straw tower. The Young modulus of the straw vary from different moisture. In this calculation, we are using that Young modulus is equal to 561.67 megapascal is at 10% of wet basic. Strain is equal to stress over E, which is Young modulus. The strain is obtained by substitute the value into the formula. Following, we are calculating the column of the straw tower by using the whole body dimension as one rigid body. For rectangle body, I is equal to BD cubed over 12, so we obtain a 3.255 10 to the power of negative 4. In order to determine the critical load, we need to first determine K. One of the n is free and another n is fixed n, so K is equal to 2. The critical load equation is pi square times E times I over KL. So the value obtained is 3.01 meganewton. Next, we will calculate the bending moment of the straw tower. Since the weight is placed in the center middle of the model, so the bending moment is equal to WL divided by 4. So the bending moment, the maximum bending moment is 15.32 Nm. We will calculate the stress in the direction of x-axis and y-axis. The stress in x-axis is 3.41 kilopascal and the stress in y direction is 5.89 kilopascal. And we calculate the torque xy of the straw tower. The result obtained is 23.545 kilopascal. After obtaining the stress in x direction and y direction, we need to identify the center and the point A in order to draw a Morse circle. The C is also equal to stress average is equal to stress x plus stress y and divide by 2. So the answer obtained is 4.65 kilopascal. And stress 1 is equal to stress average plus the radius. The result obtained is 28.228 kilopascal, whereas stress 2, the result obtained is negative 18.928 kilopascal. After all the values and angles is obtained, the Morse circles can be drawn. Following are all the calculations and formula involved in the straw towers. That's all from me. Thank you.
Hello, my name is Muhammad Aiguddin bin Safruddin and I would like to explain about the conclusion and recommendation part. This paper has analyzed the philosophies officially utilized at two foundations for carrying out the Tower of Straws movement and has given an evaluation of its anything but its functioning learning exercise in equating first year designing understudy with designing plane measure. Perceptions from an understudy overview demonstrate that understudies from two colleges yet many plane components also following this appearance. With the basic contrast clarified by the managerial attributes of action. As displayed in this paper, one can make this an exercise going in one the plane interaction finish in one class period or less, all a task covering all features of the plane cycle with more opportunity for extra investigation chipped away for a time up to 7 days. With thought from direction from the teacher, the designing plane cycle can undoubtedly be declined in one or other organization of the movement. The qualities of the tower of straws experience are that it is effortlessly adjusted to 1. Feel the volume to designing plan from get to go in term. 2. Fit in the learning target of a specific exercise. 3. Capacity to support the setup plan step later in the term. And 4. Catch the component that are neither stat related or non-substantial